In this video, we're going to look at several examples where we use integration by parts. So remember that our integration by parts formula is that the integral of u dv equals uv minus the integral of v du. And we're going to have to do some work given an integral to identify what we want to be u and what we want to be dv. So a couple of important notes. Integration by parts is useful for integrals that are a product of different kinds of functions. So something like we see in this example where we have x times e to the x, that's a product of two very different kinds of functions. Okay, and we said we're going to have to identify u as something and dv as something. So a big question is, how am I going to choose what u is and how am I going to choose what dv is in my integral? So here's our guidelines for prioritizing u. So we have this acronym called ILATE, okay, which tells us what we want to pick for our u if one of these types of functions appears in our integral. So I stands for an inverse trig function, like arctan or arcsine. L stands for a log function. Algebraic stands for something like a power of x. Okay. T stands for a trig function like cosine or sine, and E stands for an exponential function like e to the x. Okay. So we have this ILATE guideline that's telling us what we should pick for u when we have that type of function appearing. The reason that this guideline is helpful is the goal is to try to pick something for u that's easy for us to differentiate and make sure we don't put something in dv that's hard to integrate. So when I'm looking at this first example here, I have an integral of x times e to the x. So this is a product of two different kinds of functions where x is what we'd call an algebraic function because it's a power of x, and e to the x is an exponential function. Notice that we do need integration by parts here because this is a product of two different kinds of functions that I can't combine using algebra in any way. So I'm going to choose x to be my u because x is easy to integrate. It's going to become simpler when I integrate it. And for dv then, that needs to be whatever remains in my integral. So I'll let u be x, dv be e to the x. So then my du will be dx, and v will be the integral of e to the x dx. In other words, v will be e to the x. So now with these different pieces, I can apply my integration by parts formula. So I can say that the integral of x e to the x dx is equal to u times v, so where u is x and v is e to the x, so that's x e to the x, minus the integral of v, which is e to the x, times du, which is dx. And now we have a much simpler integral to deal with, so I have x e to the x minus e to the x, is the integral of e to the x is e to the x, and then plus c. So that would be our final answer for that particular example. Okay. So one thing to notice here, just remind ourselves, note that the integral of x e to the x dx was not, x squared over 2 times e to the x plus c. So we can't do the integral of a product as the product of the two different integrals. And we also see that we can't just pull out like x and make this x times the integral of e to the x. Okay, so these kinds of things are not appropriate ways to do the integral. Okay, so we did need to use integration by parts for that example. Okay, so let's look at another example here where integration by parts is going to be helpful to us. So I have this integral of x squared times sine 2x dx. I remember that my integration by parts formula says the integral of u dv is uv minus the integral of v du. And I'm going to prioritize using my iLate guideline. Okay, so what kinds of functions do I have here? I do have a product of two different kinds of functions. I've got this x squared function and this sine 2x function. So that x squared is an algebraic type function, it's a power of x, and sine 2x here is a trig function. Okay, so I want to think about what I want to be u and what I want to be dv. So think to yourself for a minute, what do you think makes sense to be u? Well, we know that my guideline here says to prioritize an algebraic thing, the a, over a t thing, a trig thing for u. So I'm going to put x squared in for u. Also, we know why we're doing this is because if I take the derivative of that, it's going to become simpler. So the derivative of x squared will become 2x du, and it's not too bad to integrate sine 2x dx. I want to make sure I don't give myself something really bad to integrate for dv. So I need to do the integral of sine 2x dx to find what my v is. It might help you to remember this little side rule about the integral of sine of like a constant times x. That will be negative cosine of kx divided by k plus c. Okay, so whenever you're doing the integral of something that's where the composition would be like just a number times x, just like in the derivative rule, I'd have to multiply by that constant. When I do the antiderivative, I can divide by that constant. And we know that the antiderivative of sine is negative cosine, because the derivative of cosine would be negative sine. So then I'd have those negative times the negative giving me back the positive sine. So here I have negative cosine of 2x over 2, for my v. So now we can apply our formula here and see what we have. We have the integral of x squared sine 2x dx is going to be uv minus the integral of v du. So uv, that'll be x squared times my v of negative cosine 2x over 2. And I'm going to have minus the integral of v du. So my v was negative cosine 2x over 2, and my du was 2x dx. Okay, so notice that we have made things a little bit simpler, but we're going to have to simplify this a little bit before I try to see what I'm left to integrate. So notice that those 2's cancel. I also here have minus and negative, so I can make that plus a positive. So we're looking at negative x squared cosine 2x over 2 plus an integral of x cosine 2x dx. Okay, so notice from what we started with, initially we had this x squared times sine of 2x. Now the integral part is just a single x times cosine of 2x. So we have a simpler integral now. We reduce the power on x, but we still have some kind of product of an algebraic function and a trig function, a product of two different kinds of functions. So this is a situation where we have to do integration by parts again. So we'll often see situations where integration by parts is needed more than once. We won't give you examples where you need to do it 10 times, but sometimes you will have to do it 2, maybe 3 times. So we have to do integration by parts again just on that piece. So I need to identify a u and a dv. Well, I want to let u be that algebraic x part, and then dv will be my cosine 2x dx. And then I can go about finding my du and my v. So du will be dx. V will be the integral of cosine 2x. Well, the integral of cosine of kx, just to give you another little rule to remember, that's sine kx divided by k plus c. So this will be sine 2x divided by 2. We're not putting the plus c's in here for the v's. The plus c will be become part of our answer at the very end. So notice what we have here now. This is negative x squared cosine 2x over 2 plus, and then we're going to be replacing this integral of x cosine 2x dx with our integration by parts formula of uv minus the integral of v du, where we have u and v defined according to this second application of integration by parts. So I'll have x times sine of 2x over 2, uv minus the integral of my v of sine 2x over 2, and then my du, which is just dx there. I'll squeeze that in. So let me just rewrite the problem that we're solving. We are trying to find x squared sine 2x dx. So that's equal to this negative x squared cosine 2x over 2 plus this x sine 2x over 2. Then I have this minus 1/2, if I pull that 1/2 constant out in front, and then I'm just integrating sine of 2x. So I know the integral of sine of 2x is going to be a negative cosine 2x over 2 plus c. So I see that this is going to become plus a positive here, and I could simplify this, but I don't need to here, into this part being cosine 2x over 4. But we can see that this is our final answer for this particular problem using integration by parts twice.